This is a good reminder that all three of these conditions have to be met for us to use alternating series tests. We got to be able to get the reliable results, right? So these are the three conditions that we need. All three conditions must be met. To use alternating series test. And the ones we've looked at so far seem to be kind of obvious, but let's look at some that maybe are not quite as obvious. So you can have a series where you are alternating in sign and you have a limit of 0, but you're not necessarily decreasing. I know that feels real weird, so let's look at an example of that. So when I look here, 1/2 to 1/4 is obviously decreasing, but then I'm going from 1/4 to 1/3. Well, wait a second, that increased. Well, let's see if the pattern holds. So from 1/3 to 1/8 decreases, but then 1/8 to 1/4 increases. So something kind of weird is going on here. So this is not a situation where the terms are decreasing. Terms do not decrease in magnitude. So I can't use the alternating series test. If we look at this more as a general term situation instead of the specific terms, we can tell that this piece right here, that one is harmonic. So that's the harmonic series. Well, I know that that harmonic series diverges. And then this series is geometric, and it's geometric with an R of 1/2. So this by itself converges, but because this one diverges, we can say that the whole series diverges. So here we're going to say that this series diverges, and it diverges because it's harmonic, right? Because, let's rewrite here. N equals 1 to infinity, 1 over n is harmonic. Or we can say by p series. We could talk about the p being equal to 1, and that's the reason why it diverges. So that's really confusing, right? I do have a limit. This is getting smaller. The limit is going to 0, but it's technically not decreasing in magnitude through every term. So that's really tricky. Another example of a situation where I'm not decreasing. So I'm looking at 1/2 to 1/3. Okay, 1/3 to 1/4. Oh, I am decreasing. Wait, Coach Sim, but then I get in here. Wait, 1/9 to 1/8? Wait, that didn't decrease. Okay, 1/8 to 1/27th, that's decreasing, but 1/27th to 1/16th? That's not decreasing. So there's something kind of weird happening here in the middle. So that's kind of what this is talking about. Again, let's kind of go back to this. Okay, terms do not decrease in magnitude. Remember, we're never looking at the sign, the positive or negative. We're only looking at the magnitude pieces. So when I look at this as a general term, as an nth term situation, that right there is a geometric series. So this is geometric with 1/2 being the n, and then that right there is geometric with 1/3 being the n. Well, they're both geometric, and they both converge. 1/2 is less than 1, and then that one right there is geometric, and obviously 1/3 is less than 1. So this series does not converge by alternating series test, but it does converge by geometric series test. And the reason is because each of these individually converge, right? 1/3 to the n. Both converge, and they both just happen to converge by geometric series test. I can look at them separately, but they both are using the same test to confirm that. Remember, if I have two converging series, I know the whole series is going to converge. A finite number plus a finite number is going to give me a finite number. So just because you're alternating and the limit is 0 doesn't necessarily mean that we are decreasing in magnitude. These are really good examples of that. We got to look a little further and a little deeper. This is a good example of a situation where I'm alternating and decreasing, but I don't get a limit of 0. So alternating signs, I can see that as I work through. 1 1.5, 1 1/3. That one's 1.25. That one's 1.2. Right? I am consistently decreasing as I move through these terms. This is your general term that we're looking at. The limit here, though, is not 0. And if you did the analysis of it, you would be able to see that. So we would say that the limit as n approaches infinity of n plus 1 over n, well, that's going to be 1, right? And then the limit as n approaches infinity of negative n plus 1 over n is going to be negative 1. So we've seen one similar to that in some of our other notes, but we can say that this series diverges. It doesn't diverge by alternating series test, though. Okay, it diverges by nth term test. So it diverges because the limit as n approaches infinity, okay, does not equal 0. So keep that in mind. Okay, we're approaching 1 and negative 1, okay, not 0. So we diverge, or the series diverges by nth term test, not alternating. And that's so tricky. It's just easy to get caught up on that. So I just want you to be careful with that.